Download this code from codegive.com, link in the description below. OK, let's dive deep into how to load API data into Snowflake using Python and schedule those tasks. This tutorial will be comprehensive and cover everything from setting up your environment to creating robust and reliable scheduled data ingestion pipelines. Tutorial: Loading API data into Snowflake with Python and scheduled tasks. 1. Prerequisites and setup. Before we begin, ensure you have the following. Python installation. Python 3.7 or later is recommended. Snowflake account. You need a Snowflake account and the necessary privileges to create databases, schemas, tables, and tasks. API access. Access to the API you want to extract data from. Make sure you understand any authentication methods, API keys, OAuth, etc., required. Python packages. Install the necessary Python packages using pip. Snowflake connector. Python, the official Snowflake Python connector. Requests, for making HTTP requests to the API. Schedule, for scheduling Python functions to run at specific intervals. Snowflake credentials. You'll need your Snowflake account identifier, username, password, database name, schema name, and warehouse name. Never hard-code these credentials directly in your script. Use environment variables or a secure configuration file. 2. Project structure. Let's create a well-organized project structure. 3. Configuration. Config.py. Create a config.py file to store your configurations. We'll use environment variables to keep sensitive information secure. Explanation. Load_dotenv. This reads environment variables from a .env file, if you have one. This is the preferred way to manage secrets. os.getonv retrieves environment variables. The second argument is a default value if the environment variable is not set. Provide meaningful defaults, but remember that these will only be used if the actual environment variables are missing. Example.env file, in the project root. Important: add the .env file to your .getinary to prevent accidentally committing your credentials to version control. 4. API data extraction, API_extractor.py. This module will contain the function to fetch data from the API. Let's create a basic example. Adapt it to your specific API. Explanation: extract_data. Constructs the API request using the requests library. Handles potential errors like network issues and invalid API responses. Parses the JSON response from the API. Logs success and failure messages using a logger object. Returns the extracted data, as a Python dictionary or list, or none if there was an error. Error handling. The try, except blocks are crucial for handling potential issues with the API request, JSON parsing, and other errors. Detailed error logging helps you diagnose problems. Headers. Include necessary headers, such as API_key, if required by the API. JSON parsing. The .json method automatically parses the JSON response into a Python dictionary or list. 5. Snowflake data loader, Snowflake_loader.py. This module will handle the connection to Snowflake and loading data into a table. Explanation: connect_to_Snowflake, establishes a connection to your Snowflake account using the credentials from config.py. Create_table, creates a table in Snowflake if it doesn't already exist. Crucially, you must define the column underscore definitions correctly to match the data you're loading. Consider using varchar with appropriate lengths for string data, int for integers, float for floating point numbers, timestamp underscore ntz for timestamps, and other appropriate Snowflake data types. The function also includes error handling. Asterisk load underscore data loads the data into the specified table. This function needs careful adaptation based on the structure of your API data. Asterisk cursor.executamini, this is the most efficient way to insert multiple rows into Snowflake. It takes an SQL statement and a list of tuples, where each tuple represents a row to be inserted. Asterisk con.commit, this is essential to persist the changes to the database. Without it, your inserts will be lost. Asterisk con.rollback, if an error occurs during the executamini operation, the rollback command will undo any changes made in the current transaction, ensuring data consistency. Asterisk error handling. Asterisk the code includes try, except blocks and logging to handle potential errors during connection, table creation, and data loading. Rollback on errors is important for data consistency. 6. Scheduling, scheduler.py. This module orchestrates the data extraction and loading process and schedules it to run at regular intervals. Explanation asterisk. Asterisk job, this function encapsulates the entire data ingestion process. Asterisk extracts data from the API using API_extractor.extract_data. Asterisk connects to Snowflake using Snowflake_loader.connect_to_Snowflake. Asterisk creates the table, if it doesn't exist, using Snowflake_loader.create_table. Asterisk loads the data into Snowflake using Snowflake_loader.load_data. Asterisk closes the Snowflake connection. Asterisk includes comprehensive error handling with logging. Asterisk run_scheduler. Asterisk sets up the schedule library to run the job function at a specified interval, example every hour. Asterisk uses an infinite loop to continuously check for pending scheduled tasks and execute them. The time.sleep, 60, ensures that the loop doesn't consume excessive CPU resources. Asterisk scheduling intervals. Asterisk the schedule library provides various scheduling options. Asterisk schedule.every.hour.do, job, runs the job every hour. Asterisk schedule.every.day.at, 10:00.do, job, runs the job every day at 10 a.m. Asterisk schedule.every.monday.do, job, runs the job every Monday. Asterisk refer to the schedule library documentation for more details. Asterisk logging. Asterisk the scheduler also uses the logger to record when the job is executed and any errors that occur. 7. Logging setup. The code snippets above include a setup_logger function. This is how you can create the function if you haven't already. 8. Running the scheduler. To start the scheduler, simply run the scheduler.py script. The script will run indefinitely, scheduling and executing the data ingestion job at the specified interval. You can stop the script by pressing Ctrl+C. 9. Snowflake tasks, advanced scheduling. While the schedule library is convenient, a more robust and Snowflake integrated approach is to use Snowflake tasks. Snowflake tasks allow you to define and schedule SQL statements, including calls to stored procedures written in Python, directly within Snowflake. Steps to implement Snowflake tasks. 1. Create a stored procedure, Python. First, create a stored procedure in Snowflake that encapsulates your data ingestion logic. This will call your Python modules, essentially wrapping the existing job function. Key considerations for Snowflake stored procedures asterisk runtime version, specify the Python runtime version. Packages, list any external Python packages your code requires. Handler, specifies the name of the function to execute when the stored procedure is called, in this case, main. *Snowflake module use the *Snowflake module, provided by Snowflake, for logging and connecting to Snowflake within the stored procedure. This handles authentication internally. Logging within Snowflake use _snowflake.logger.snowflake handler to write log messages to Snowflake's event tables. Context object the context object is passed to the main function and is used for authentication and accessing the Snowflake environment. You must pass this context object to _snowflake.connector.connect, context equals context. Error handling robust error handling is crucial within the stored procedure, as any uncaught exceptions will cause the task to fail. Return values return a string to indicate the success or failure of the stored procedure. To create a Snowflake task. Create a Snowflake task to schedule the stored procedure. Warehouse, specify the warehouse to use for executing the task. Schedule, define the schedule using either a simple interval, example 1 hour, or a cron expression. Cron expressions are more flexible for complex schedules, example run at specific times on specific days. See the Snowflake documentation for details on cron syntax. As call load API data, specifies that the task should execute the load API data stored procedure. 3. Resume the task. Tasks are initially created in a suspended state. You must resume the task to activate the schedule. Monitoring Snowflake tasks You can monitor the execution of Snowflake tasks using the Snowflake web interface or by querying the task_history view. Advantages of Snowflake tasks Centralized scheduling Scheduling is managed directly within Snowflake, eliminating the need for external schedulers. Monitoring and logging Snowflake provides built-in monitoring and logging capabilities for tasks. Dependency management tasks can be chained together to create complex workflows. Error handling Snowflake provides mechanisms for handling task failures, such as retries. Scalability and reliability Snowflake tasks are designed for scalability and reliability. 10. Error handling and monitoring. Logging implement comprehensive logging throughout your code to track the execution of the data ingestion process and identify any errors. Use appropriate log levels, info, warning, error, to categorize messages. Exception handling wrap your code in try, except blocks to catch potential exceptions. Log the exceptions and take appropriate actions, such as retrying the operation or sending an alert. Monitoring monitor the execution of your scheduled tasks to ensure they are running as expected. Check the logs for errors and track key metrics, such as the number of records loaded. Snowflake provides system views and functions that you can use to monitor task history and performance. Alerting set up alerts to notify you of any errors or failures in the data ingestion process. You can use email, Slack, or other notification channels. Data validation implement data validation checks to ensure that the data being loaded into Snowflake is accurate and consistent. 11. Optimizations. Batching when extracting data from the API, consider retrieving data in batches to reduce the number of API calls. If the API supports pagination, use it to efficiently retrieve large data sets. Compression. If you're dealing with large amounts of data, consider compressing the data before loading it into Snowflake. Snowflake supports various compression algorithms. Data types. Choose appropriate data types for your Snowflake columns to optimize storage and query performance. Partitioning and clustering. Consider partitioning and clustering your Snowflake tables to improve query performance for large data sets. Caching. Cache frequently accessed data to reduce the load on the API and improve performance. Complete example with Snowflake tasks. Here's a fully worked example incorporating all the best practices, including Snowflake tasks and comprehensive error handling. It assumes a REST API that returns JSON data. Important. You'll need to adapt the table and column definitions, the API endpoint, and any data transformations based on your specific API. This example emphasizes the Snowflake task approach, which is generally more robust for production deployments. Assumptions. You have a Snowflake account and the account admin role. You have a warehouse named compute_wh created in Snowflake. You have created a database and schema to store the API data. Here's a simplified version. 1. Set up your Python environment, same as before. 2. Prepare Python scripts. Prepare the Python scripts to be run on Snowflake via stored procedures. This can be done via Snowsite IDE or terminal, see sample commands below. 3. Set up the stored procedure. SQL. Create or replace procedure load_API_data. Return string. Language Python. Runtime_version equals 3.8 or your desired Python version. Packages equals Snowflake connector Python. Requests include any external packages. Handler equals main. As $. Import_Snowflake required when running in Snowflake. Import requests. Import JSON. Import logging. From config import Snowflake_account, Snowflake_user, Snowflake_password, Snowflake_database, Snowflake_schema, Snowflake_warehouse, Snowflake_role, API_endpoint, API_key. Import time. Configuration inside the stored procedure, if needed. Table_name equals API_data. Column_definitions equals ID varchar, 255. Name varchar, 255. Value int. Processed_at timestamp_ntz. Def setup_logger, context. Sets up a basic logger using Snowflake's logging functionality. Logger equals logging.getLogger, __name__. Logger.setLevel, logging.info. Formatter equals logging.formatter, %, s, level name, s, message, s. Use Snowflake's logging context to write to Snowflake's event tables. Handler equals _Snowflake.logger.Snowflake handler, context. Handler.setFormatter, formatter. Logger.addHandler, handler. Return logger. Def extract_data, logger. Extracts data from the API. Try. Headers equals if API_key. Headers x API key equals API_key. Adjust header name as needed. Response equals requests.get, API underscore endpoint, headers equals headers. Response.raise underscore for underscore status, raise an exception for bad status codes, 4xx or 5xx. Data equals response.json, assuming the API returns JSON data. Logger.info, successfully extracted data from the API. Return data. Accept requests.exceptions.request exception as e. Logger.error, f error during API request, e. Return none. Accept JSON.json decode error as e. Logger.error, f error decoding JSON response, e. Return none. Accept exception as e. Logger.error, f an unexpected error occurred, e. Return none. Def connect underscore to underscore Snowflake, logger, context. Connects to Snowflake and returns a connection object. Try. Con equals underscore Snowflake dot connector dot connect, context equals context. Logger.info, successfully connected to Snowflake. Return con. Accept exception as e. Logger.error, f error connecting to Snowflake, e. Return none. Def create underscore table, con, table underscore name, column underscore definitions, logger. Creates a table in Snowflake if it doesn't exist. Try. Cursor equals con.cursor. Create underscore table underscore SQL equals f. Create table if not exists table underscore name. Dot join, column underscore definitions. Cursor.execute, create underscore table underscore SQL. Logger.info, f table underscore name created, if it didn't exist, or already exists. Accept exception as e. Logger.error, f error creating table underscore name, e. Finally. Cursor.close. Def load underscore data, con, table underscore name, data, logger. Loads data into the Snowflake table. Try. Cursor equals con.cursor. Assuming data is a list of dictionaries, prepare the values for insertion. Important, adapt this part based on the structure of your API data. If not data. Logger.warning, no data to load. Return. Determine column names from the first record. Columns equals list, data 0.keys. Placeholders equals, dot join, %s asterisk len, columns. Column underscore names equals, dot join, columns, properly escape the column names. Insert underscore SQL equals f insert into table underscore name, column underscore names, values, placeholders. Prepare the values for insertion, as a list of tuples. Values equals tuple, record col for col in columns, for record in data. Cursor.executamini, insert underscore SQL, values. Con.commit, important, commit the transaction. Logger.info, f successfully loaded len, data, records into table underscore name dot. Accept exception as e. Logger.error, f error loading data into table underscore name, e. If con.rollback, roll back the transaction on error. Finally. If cursor.close. Def main, context. Main entry point for the stored procedure. Logger equals setup underscore logger, context. Try. Log start time. Start underscore time equals time.time. Logger.info, f starting load underscore API underscore data at time.struct time, %y dash %m dash %d %h %m %s, Time.local time, start underscore time. 1. Extract data from the API. Data equals extract underscore data, logger. If data. 2. Connect to Snowflake. Con equals connect underscore to underscore Snowflake, logger, context. If con. 3. Create the table.